Hello everyone. Today we're going to talk about cross-platform frameworks in mobile development. Whenever a new technology comes out, we always like to ask what it is and how it works. But before we look at what cross-platform frameworks are, we'd like to introduce to you why we need them. Let me tell you a story that can help you understand what problems we may meet when developing apps using a native framework. Michael has a billion-dollar idea and wants to build an application. He's an experienced Android developer, so he spent half a year to create the first release for Android devices. His app immediately became a huge success, and Michael has been getting many requests to develop an iOS version. Now Michael has a problem. There's no simple way for him to adapt his code. Also, he would have to maintain and update two separate code bases in order to keep his app consistent across devices. Instead of spending much time learning iOS development himself, Michael decides to hire a team of iOS developers to write the code under his guidance. After months of work, countless meetings, and many payments to the iOS developers, he still feels the iOS version is inferior to the one he created for Android. The design is inconsistent and the app works differently from the Android version. He then meets his friend Anna and tells her about his disappointment. She understands his problems with native app development. She then tells him about her experience using a cross-platform framework called React Native and how it could solve his problems. Michael now starts to learn React Native and immediately realizes the overlap with JavaScript, which he already knows from his web development experience. He's amazed by the fact that he can write one program using one coding language to run on both iOS and Android devices. Additionally, he does not have to worry about inconsistent user experience anymore, as the layout is derived from the same code and all application features work the same way. Looking back at his previous experience, he realizes that he could have avoided many meetings by communicating with his developer team using a shared programming language. Also, he would have required less developers to maintain and extend his application. Overall, he would have saved money, time, have a better experience with his team, and create a better application, reaching a wider audience. Now that you have heard about Michael's story, you probably know the reasons for using cross-platform frameworks. But you may still not be sure about what a cross-platform framework exactly is. Let me try to break it down for you. This diagram might help you understand. A cross-platform framework is a set of tools that allows you to build native or native-like apps for multiple platforms such as Android, iOS, Windows, macOS, or even web browsers with a single code base. In the past, mobile developer teams had to learn at least two programming languages to support the two biggest platforms, iOS and Android. Nowadays, cross-platform frameworks provide you with an interface, so your team only needs to learn one programming language, which can support multiple platforms. The framework will do the work for you. This enables you to expand your reach to a much larger target audience on multiple platforms at a significantly reduced cost and time. Let me give you a few examples of current top-performing frameworks. They are Flutter, React Native, and Xamarin, developed by the major companies Google, Facebook, and Microsoft. Although these frameworks are new in mobile app development, they have already revolutionized the industry. It's hard to say which of them is the best option. Most of the time it depends on your specific requirements, since all three frameworks have their advantages and disadvantages. Let me give you a quick overview of their pros and cons to help you decide which framework would be best suited for you. Flutter provides many widgets for developers. These widgets are designed in Material style. Additionally, Flutter has a large community that can help developers discuss and fix their issues as soon as possible. However, apps built with Flutter often are bigger in size compared to other frameworks. In terms of React Native, it has a simple learning curve, as its underlying programming language is JavaScript, which is one of the most popular programming languages. But what needs to be noticed is that while React Native uses JavaScript for its development, it does not render inside WebView. It also offers to write platform-dependent code blocks. One downside is that it still hasn't released its 1.0 game-changing version, which means that its growth is slow and there might be major changes to come. Xamarin currently has less popularity than Flutter and React Native. It supports linking with native libraries and platform-specific UI elements. It also has powerful development tools for the developers from Microsoft, for instance Visual Studio, C#, .NET, and many others. However, if your app requires rich graphics, Xamarin is not a good choice. Now you may want to know how these frameworks work. However, different cross-platform frameworks have different architectures. We chose React Native to give you a deeper explanation. React Native is a framework which allows developers to build native apps using JavaScript. You may think that Cordova already does that, and it has been around for quite a while. Why would anyone want to use React Native? The primary difference between React Native and Cordova-based apps is that Cordova-based apps run inside a web view, while React Native apps render using native views. React Native apps have direct access to all the native APIs and views offered by the underlying mobile operating system. Thus, React Native apps have the same feel and performance as native applications. Besides, React Native doesn't directly compile JavaScript code into native code. Instead, React Native can be considered as a set of React components that represent the corresponding native views and components. Here is a general architecture for React Native. There are three major parts: native modules, React Native Bridge, and JavaScript virtual machine. The JavaScript virtual machine runs all our JavaScript code, and it uses a JavaScript engine called JS Core, which is originally built for WebKit. JS Core is naturally provided in the iOS platform, but not in Android. So for Android, React Native has to bundle JS code along with the application. This results in minor increases of the app size for the Android platform. Native modules are platform dependent. In iOS, they are written in Objective-C or Swift. For Android, they are written in Java or Kotlin. The React Native Bridge is a C++ Java bridge which is responsible for communication between the native side and JavaScript virtual machine. Let's have a look at a detailed description of the React Native Bridge. There are three threads, one for JavaScript, one for the native UI, and the last one for Yoga. Based on this architecture, the JavaScript side will communicate with the bridge by using a JSON format. It works the same way on the side of the native modules. Thus, we can use JavaScript to touch native modules. The reason why we need the layout engine Yoga is that Flexbox is a really popular layout. If we want to integrate it into native development, then we have to use this engine. That is all for now for how React Native works under the hood. Now we will show you how easy it is to experience React Native development on your phone. First, you need to download an app called Expo from Google Play or App Store. This app has already been installed on my phone. Here you can see what the app icon looks like. Second, open your browser and enter the URL expo.dev/snacks. After signing in, you can see a button on the top right corner. Click it to create a new snack project. Now we have a really simple React Native app in debug mode. Change the text here, type the classical hello world. I don't even need to save it will update automatically. You can also use the Expo app you just downloaded to scan this QR code and test it on your phone. Let's try it on an Android virtual emulator. Just press tap to play. It takes a few seconds to start a device. Once it's finished loading, we can see the virtual emulator of an Android phone. Now we can add more text. For example, this is Android. Amazing. Just wait a few seconds and here it is. Another amazing feature I want to introduce is Code Push, a library designed for React Native. Code Push changes the way for developers to deliver application updates. The common way to distribute updates is to compile a new version, upload it to the relevant app store, and notify users that a new download is available. With Code Push, you can simply launch updates through a proprietary server and they will be directly installed. This allows you to deliver updates faster and requires less time of your users. Imagine having to upload a new version to an app store to fix a crucial bug when instead you could push the fix immediately to all users. Libraries like Code Push make React Native more preferable compared to native development or even other cross-platform frameworks. Today, thanks to emergent technologies, cross-platform development has become more robust and versatile than ever. However, cross-platform frameworks still have some issues that need to be improved, such as a slight performance gap and long wait times for support of new features. We do believe that cross-platform frameworks have a great future ahead, and we are looking forward to seeing its value on many other domains like smart wearables, VR devices, and many others.